Square of period of revolution of the planet is directly proportional to the cube of the semi-major axis. Okay. So the as we have shown here the elliptical orbit. And for an elliptical orbit, we have an equation from the Kepler's first law, that is this L upon R is equal to 1 plus E cos of theta minus theta naught. Okay, that is the equation of conic section जो अपन already पाहिलेलं होतं. Now we have two turning points, the point A and point B. Let us say at point A the angle is equal to 0. So, I'll just say at point A, the angle theta minus theta naught is equal to 0, and that's why the cos of this theta minus theta naught is equal to plus 1. So, I can write for this point L upon R1 is equal to 1 plus E. That is the first thing. Q1 is going to be right. So, I can write this is equal to R1 is equal to R1 is transferred to your RHS, so this is L upon 1 plus E, first thing. And at point B, okay, let us say this angle theta minus theta naught is equal to pi. At point A it is equal to 0, and at point B it is equal to pi, 90 plus 90. So this cos of theta minus theta naught, that is cos of pi, is equal to minus 1. And that's why this equation that can be written as L upon R2 is equal to 1 minus E. Or what we can say? We can write that as R2 is equal to L upon 1 minus E. So you can have these equations. Now, the point is, just check it out, the values of this R1 plus R2. So I have these values, that is R1 plus R2 is equal to twice A. What is this distance from O to A? This is your semi-major axis, and that semi-major axis is having a distance that is equal to small a, same from point O to B. So we can have this R1 plus R2, that is the total distance, and which is equal to twice A. Now, I will have to use this R1 and R2 at these places, and so I can write this as L upon 1 plus E plus L upon 1 minus E, and that is equal to twice A. And so I can write this as that is twice L, LCM bar, that is equal to 1 minus E square, and that is equal to twice E. Now, we have seen the two conditions, one is eccentricity and second one is the semi-radius vector. So you can have their values. The value of semi-radius vector, that is nothing but L is equal to small l is equal to L square upon mk, first thing, and the value of eccentricity is nothing but 1 plus twice EL square divided by mk square. दोन गोष्टी आपण already first one as derive केला त्या ठिकाणी पाहिलेला आहे. So these are the two things. So I have to put these values of L and E in these equations, and I can write that is 2 into L. So L is nothing but L square upon mk, that is divided by 1 minus E square. So E square is, I can remove this square root, and so minus 1 minus this twice EL square divided by this mk square, and that is equal to twice E. So I can write this as these equations, and I can write, so this 1 minus 1 that will get cancelled out, and I can write that is 2 L square upon mk, okay, which is multiplied by, so this is a negative sign, so I can write this in terms of minus this mk square divided by this twice EL square, and that is equal to twice E. Okay, A just gets flipped, and you can have that in terms of mk square upon twice EL square. So हा m या m बरोबर कॅन्सल होऊन जाईल, हा 2 कॅन्सल होऊन जाईल, हा k या k स्क्वेअर बरोबर कॅन्सल होऊन जाईल, हा l स्क्वेअर हे l स्क्वेअर बरोबर कॅन्सल होऊन जाईल. काय शिल्लक राहणार बा माइनस k upon e is equal to twice e, or I can say the energy is equal to minus k upon twice a, or I can say modulus of an energy is k upon twice a. So what is this? What you can say? You can say that the energy of any planet which is moving around the sun, okay, in an elliptical orbit, its energy that depends on a thing that is called as a small a. What is that? That is nothing but a semi-major axis. So we can say the energy depends upon semi-major axis. फर्स्ट ला ज्यावेळेस आपण पाहत होतो केपलरचा प्लॅनेटरी मोशनचा, त्यावेळेस आपण पाहिलं की इसेंट्रिसिटीची व्हॅल्यू आहे स्क्वेअर रूट ऑफ 1 प्लस ट्वाइस एल स्क्वेअर अपॉन एम के स्क्वेअर. So the value of eccentricity, that is decided by the value of energies. So what should be the amount of energy? So that amount of energy that will decide the shape of an orbit. ठीक है, मगाशी जसं सांगितलं, either it is hyperbola, parabola, circular ellipse, that is decided with the help of this energy value, whether it is minimum energy value or a maximum energy value. And so we can have this value of energy is equal to k upon twice n. So this is one part. Now, in order to derive this law of planetary motion, third law, I'll just use a Kepler's second law. So what is your Kepler's second law? So Kepler's second law just tells us that the area velocity is constant, or your planet sweeps out equal areas in equal interval of time. So what is the conditions? The conditions are like this. We can have dA by dt is equal to L upon twice n, or I can write this dt is equal to twice m upon L into d. I'll just change this, just have a equation in terms of dt, and so that dt is equal to twice m upon L into dA. So what is dA? dA is nothing but the area, okay, area covered by the particle or a planet. How much area it is covering? That is equal to the area of ellipse. एखादा planet suppose इधर है तो कितनी area cover करता है? So it will cover the area which is equal to or which is equivalent to the area of ellipse. So what is the area of ellipse? पाठीमागच्या वर्षी एमएमपी मध्ये आपण पाहिलं, ज्यावेळेस आपण पार्शियल डिफरन्शिएशनचे वगैरे प्रॉब्लेम सॉल्व करत होतो, त्या ठिकाणी एक इलिप्सचा प्रॉब्लेम होता. सो आय होप यू कॅन रिमेंबर दॅट द एरिया ऑफ इलिप्स इज नथिंग बट पाई टाइम्स a into b, पाई टाइम्स semi major axis into semi minor axis. So I am going to use these conditions here, but असं होत नाही that planet is suddenly moving. ठीक है, it requires some time. So how much time will it require? I'll just say it moves from an initial point 0 to a final point tau. So tau is the amount of time that is required to have a one complete round. ठीक है, एक period जो है पहले period calculate करायचा है. So what is period? Period is nothing but the time required for a planet to complete one oscillation. The sun च्या भोवती एक oscillation complete करण्यासाठी लागणारा जो काही time आहे, let us say we define it in terms of tau, and so you can have that 0 to tau dt is equal to integration from 0 to a, that is the amount of area that is covered, that is twice m upon l into this dA. So this is tau is equal to twice m upon l multiplied by the value of a. A is the area of an ellipse, so this is twice m upon l multiplied by pi a into b. So what is this tau? Tau is nothing but twice m upon l into pi not the Kepler's third law. काय स्टेटमेंट होतं? स्क्वेअर ऑफ द पिरियड ऑफ द रिव्हॉल्यूशन ऑफ द प्लॅनेट. स्क्वेअर ऑफ द पिरियड, जो काय आपण पिरियड घेतोय त्याला काय करायचं आपल्याला? स्क्वेअर करायचं. सो स्क्वेअर ऑफ पिरियड ऑफ रिव्हॉल्यूशन ऑफ प्लॅनेट इज proportional to the cube of semi major axis. And so in order to have that equation and use one more equation, that is the relation between the semi major and the semi minor axis, and that relation is given as A is equal to B square upon L, or you can say this B square is equal to A into L, or this B is equal to square root of A into L. So you can have these conditions. I'll just put it here and I can write the value of this tau square, tau is equal to this twice m upon L into this pi into this A multiplied by the value of B, that is nothing but square root of A into L. So I'll just square this and I can write that in this tau square is equal to 4 2 square. This is m square pi square upon L square multiplied by this A square into square of this is nothing but A into L. What you can write? I can write this is equal to tau square is equal to 4 pi square m square upon L square multiplied by this A cube into L. What is L? L is the value of semi-lattice vector, and that value of L is nothing but L square upon mk. So I'll just put it here and I can write that tau square is equal to 4 pi square m square upon L square multiplied by this A cube and multiplied by this L square upon mk. Okay, and what we can say, this is we cancel out this m square, we can cancel out with this m, and I can write that is equal to this tau square is equal to 4 pi square m upon k multiplied by E cube. So 4 is constant, pi is constant, m is constant, k is constant. What you can say? You can say this, that is tau square is proportional to A cube. So that is Kepler's third law. That is the square of period of revolution of the planet that is proportional to the cube of the semi major axis. Let us say we'll apply it to some planet. Okay? And I can have that equations which just say what should be the period and what should be other conditions, and have that look. So for this, the k is nothing but constant, gravitational constant into this ms into this mp. ठीक है, आपण ऑलरेडी डिफाइन केलेलं होतं, सगळ्यांच्या लक्षात असेल. The gravitational force is nothing but G m upon r square, that is central force. So what you can say? I can write this in terms of mass of sun and this is in terms of mass of planet. So I have replaced it as minus k upon r square. So I can just say k is nothing but G times ms into mp, and so I can write that values. So one more thing. We have a two-body problem. We have already used that conditions. Now we have to change two-body problem in the sense we can have a sun as well as a planet. So we can say let us say the reduced mass that is given in terms of mass of sun into mass of planet divided by mass of sun plus mass of planet. What is reduced mass? We represent it in terms of mu, and that mu is nothing but m1 m2 upon m1 plus m2. So we do not have an m1 m2, so we can have that is mass of sun into mass of planet divided by mass of sun plus mass of planet. And now I can use it here, and I can write that this tau square is equal to this 4 pi square, okay, divided by this k is nothing but G into this ms into mp multiplied by this m is nothing but ms mp divided by this ms plus mp, and it is multiplied by a cube. So this ms mp that will get cancelled out, and what you can say, we have a tau square is equal to 4 pi square divided by this g into mass of sun plus this mass of planet multiplied by a cube. What are the conditions now? The conditions are like this. You can have the mass of sun is very greater than the mass of planet, and so you can write that is ms plus mp, that is approximately equal to the mass of sun, and so I can write that tau square is equal to this 4 pi square divided by this g into ms multiplied by a cube. Or what you can write? You can write that tau square is proportional to e cube. So again the same thing, the square of the period of the planet is proportional to the cube of the semi-major axis. So tau square is directly proportional to e cube. So that is the one part. आता आपल्याला याच्यामध्ये पाहायचं what will actually happen when you apply it to some particular bodies. Okay. म्हणजे आता हा तुम्ही केपलरचा थर्ड लॉ आलेला आहे, बऱ्याच वेळा हा टाउ स्क्वेअर जो आहे किंवा टाउ जो आहे that is replaced by a symbol that is t, both are having the same meaning. Okay, so we can have to replace these conditions in terms of a moon or in terms of a sun. What will happen actually in that particular case? We'll have to look at this conditions. So remember that every planet moves around the sun in an elliptical orbit. Okay, with sun being at one of the foci of the orbit. That is the first statement, Kepler's first law. The second statement is the aerial velocity is constant, or the planet sweeps out equal areas in equal interval of time. We have particular area, so that planet that sweeps out equal areas in that particular equal interval of time. Third thing is that the square of the period of the revolution of the planet is proportional to a semi-major axis. So you can have this third thing. काय केलं होतं अगोदरच्या याच्यामध्ये आपण दाखवलं की एनर्जी इज कॉन्स्टंट. ओके, नाउ फॉर दिस cases we can have the condition that is energy that depends upon the semi-major axis. Whether we can have conditions that is eccentricity that will depends upon the energies that will decide the shape of the orbit, and so we have to use all that things in order to derive your Kepler's third. So now we have some problems. Very interesting problem is there. Let's just look at this first problem. Simultaneously, you can just take it down. The problem is the distance between Sun and Earth. The distance between Sun and Earth, I'll write it here. The distance between Sun and Earth is suddenly reduced to half of its present distance. To half of its present distance. Okay, the question is, what will be the duration of year? What will be the duration of year? प्रॉब्लेम एकदम सोपा आहे, परंतु त्याबरोबर विचार करायला लावणार देखील. असं झालं की फिरता फिरता एकदम सूर्य आणि पृथ्वी मधलं अंतर एकदम हाफ होऊन गेलं. जे काय सध्याचं डिस्टन्स आहे त्याच्यापेक्षा ते जर हाफ झालं. सो तो प्रश्न असा विचारला आहे की व्हॉट इज द ड्युरेशन ऑफ इयर, जे आता 365 दिवसाचं असतं तर ते किती होऊन जाईल हे आता त्यांनी आपल्याला विचारलं. सो दॅट इज टोटली रिलेटेड टू युअर थर्ड लॉ. सो वी कॅन हॅव दॅट कंडिशन्स. I just said let we can have the r1 is the present distance. काहीतरी present distance आपण assume करूया and t1 is the period. ठीक आहे, t1 हा पिरियड कन्सिडर करूया 365 दिवसाचा आणि r1 हे त्यांच्या दोघांमधलं डिस्टन्स. लेट r2 is the new distance and for that t2 is the period. That is the period of revolution. So as we can have these conditions, r1 is the point. Now problem is what is the given conditions? The conditions are given like this. The distance that is reduced. And how much reduced? The distance is reduced to half of its present distance. What is the present distance? Present distance is r1. So distance is reduced to its half. So the distance, that is the new distance, it is given in terms of the value that is r2. So r2 is equal to r1 upon 2. So that is the new conditions. Now, what is our relation? Our relation is the square of the period is directly proportional to the cube of a semi-major axis. Now we can have a conditions, that is we can consider that is in terms of your distance r1 and r2. So this t square is proportional to r cube. Okay, so this is, you can say, the Kepler's third law. Now for first case you can say t1 square is proportional to or that is equal to this r1 cube, and for the second case when the distance is decreased you can say this t2 square is equal to this r2 cube. What we have to find out? We have to find out the value of t2, and so I can just take a ratio of this, that is t1 square divided by t2 square, which is equal to r1 cube divided by this r2 cube, or I can write that t1 divided by t2 which is equal to r1 cube or r1 upon r2 याचा cube. आणि काय केलंय इकडच्या बाजूला आपण काय केलेलं आहे स्क्वेअर रूट घेतलेलं आहे. सो इकडे स्क्वेअर रूट घ्यावं लागेल and so you have to divide it by 2. So I can just have a power of this and I can write that the values that is power arrange केल्या rearrange केल्या and I can write t2 is equal to किती येते पहा. So this t2 can set and just change this and I can write that this t2 is equal to how much? t1 times. Just check the values and we can have the ratios t2 upon t1 that is equal to what we will get? This is r2 divided by r1 raised to 3 by 2. And now let's put the values. t2 is equal to, we have one more thing, that is t1 is equal to 365 days 365 दिवस एक revolution साठी, and so this is multiplied by 365 multiplied by this r2 is nothing but r1 upon 2 divided by this r1 raised to 3 by 2. This r1 that we can cancel out and we can have this t2 is equal to this 365 multiplied by this 1 half raised to 3 by 2. We just calculate it out and we can have these values. So we'll have this, that is 1 half raised to 3 by 2, and that value that comes out to be I think 129 days. So this is your problem. Condition is when the distance is suddenly reduced to half of its present distance, then your number of days that will decrease from 365 to 129. ठीक है, म्हणजे जवळपास त्याच्या हाफ जो काही टाइम पिरियड आहे त्या हाफ टाइम पिरियड पेक्षा कमी त्याचे दिवस होतात किंवा रिव्होल्यूशन होते. आणि जर सूर्य एवढ्या जवळ येत असेल आपल्या when the distance is suddenly reduced to half of its distance, मला वाटतं इथं काहीच राहणार नाही, सगळं संपून जाईल. ठीक आहे, आताच टेम्परेचर जे आहे आपलं 45-50 पर्यंत जात आहे आणि ते जर अजून जवळ आलं तर टेम्परेचर खूप जास्त वाढेल. जर टेम्परेचर खूप मोठ्या प्रमाणात वाढलं तर विदिन अ फ्यू डेज सगळं काय जे आहे ते सगळं संपून जाईल. सो यू कॅन हॅव दिस प्रॉब्लेम, यू कॅन रिमेंबर दिस कंडिशन्स. कशा पद्धतीने हे सॉल्व्ह केले पहा, परीक्षेला देखील विचारलं जातं. सो यू कॅन हॅव दिस वन कंडिशन्स फॉर युअर डिस्टन्स बिटवीन सन अँड अर्थ इज सडनली रिड्यूस्ड टू हाफ ऑफ इट्स प्रेझेंट डिस्टन्स. What will be the duration of the year? There are a few more problems which are quite simple. I'll just have one more. We have 10 minutes left for this lecture. After that I will end that. So you can have that conditions. The problem is the eccentricity of the Earth orbit of the Earth orbit is 0.0167. Is 0.0167. So that is the eccentricity. Calculate the ratio of maximum to minimum speed. Calculate the ratio of maximum to minimum speed of the Earth in elliptical orbit. Of Earth in elliptical orbit. Problem is like this. So what is given? The given thing is if eccentricity is given, there is nothing but 0.0167. Okay. So for elliptical orbit, we can have an equation that is L upon R is equal to 1 plus E into cos of theta, or theta minus theta naught. So that is your equation. आपल्याला काय विचारलं आहे? आपल्याला विचारलं आहे की मॅक्सिमम टू मिनिमम स्पीड. ठीक आहे, आता ज्यावेळेस आपण थर्ड ला पाहत होतो त्यावेळेस तुम्हाला सांगितलं वी हॅव 2 पॉइंट्स. सो इन टर्म्स ऑफ दिस, so this is your sun, this is your point A, okay, this is your point B. So this is distance R1, this is distance R2 from your sun, and so for that we can have a conditions. That is, at point A the planet that will move with a higher velocity given as compared to point B. So V1, it is nothing but the maximum velocity, and V2 is nothing but the minimum velocity. So we'll just say at point A this theta minus theta naught is equal to 0, and therefore this cos of theta minus theta naught is equal to 1, and so I can write that is L upon R1 is equal to 1 plus E. First thing. The second thing is, at point B, this theta minus theta naught is equal to pi, and that's why this cos of theta minus theta naught is equal to -1. And so we can write that is L upon R2 is equal to 1 minus E. So we can have 2 points. The point is like this: R1 is equal to L upon 1 plus E, and this R2 is equal to L upon 1 minus E. So we'll just take a ratio, that is this R2 divided by R1. आपल्याला काय विचारलंय? आपल्याला विचारलंय ratio of maximum to minimum speed. So you can just say this R2 upon R1 is equal to this L upon 1 minus E divided by L upon 1 plus E. L cancel on जाईल, and you can write this 1 plus E upon 1 minus E. So R2 upon R1 is equal to 1 plus E divided by 1 minus E. The planets are moving at its 2 points. Okay, at point A and at point B. So the conditions with respect to this, there are 2 conditions. I'll just say that is the angular momentum. So the particle is moving in an elliptical orbit. We have 2 points, and at these 2 points we have 2 angular momentum. So I can just say, as the angular momentums are conserved, angular momentum are conserved during the motion, I can say this m1. What is angular momentum? Angular momentum is n is equal to r cross p. What is this p? P is nothing but mass into velocity. So we can write the magnitude as mvr. So I can just say m1 v1 r1 is equal to m2 v2 r2. बरोबर? So angular momentum before and after we can have that same point, but the mass is same. There is only one planet which is moving. So we can say this m1 is equal to m2, and so we can have these points. So this m1 that will get cancelled out, and I can write this as this r2 upon r1. This r2 divided by r1, r2 divided by r1, which is equal to v1 divided by v2. And after this सांगितलं, we can have this v1 is nothing but maximum velocity, and v2 is nothing but the minimum velocity. Okay, and so I can write that is v max upon v minimum, which is equal to this thing 1 plus E divided by 1 minus E, and that is nothing but 1 plus 0.0167 divided by 1 minus 0.0167. So you can have this, the ratio V max to V minimum. Just take it out, and you can have that value that comes around to be 1.03. Okay, so that is the problem. High problem परीक्षेला विचारला जातो. So you can just remember this simple conditions है. आपल्या ज्या काही कंडिशन्स दिलेल्या आहेत इलेक्ट्रिकल ऑर्बिट साठी त्याच फक्त आपण यूज केल्या. फक्त हे लक्षात राहिले पाहिजे की हे जे v1 आहे आणि v2 आहे. सो विथ रिस्पेक्ट टू r1 जे काही क्लोजेस्ट डिस्टन्स ऑफ अप्रोच आहे, ओके, तर त्याच्यामध्ये आपण त्याला काय म्हणतोय, इट इज हॅविंग अ मॅक्सिमम स्पीड, आणि जे काही फादर डिस्टन्स आहे इट इज हॅविंग अ मिनिमम स्पीड. सनच्या जवळ असेल, so when it is moving close to sun, its speed is increasing, ठीक है, and when it is moving further than that, we can have that the speed is minimum. So v max to v minimum, that depends upon these values of r2 and r1, and so you can have that v max to v minimum is equal to 1.03. So that's all for your today's conditions. एक शेवटचा पॉइंट